Today our question is derive the expression for the intensity at a point where interference light occurs. Derive the condition for maximum and zero intensity. So we have to find the expression for intensity expression. First we have to derive in terms of interference of light, and we have to satisfy the conditions for maximum intensity and zero intensity, minimum intensity. Okay, this question belongs to wave optics, which carries 4 marks. Okay, so let us consider two slits. This is slit 1, this is slit 2, two slits. This is O, this is screen. Okay, so this is source of light, which is monochromatic source. Whenever the source enters into these two slits, they interfering with each other and they form a beam at point P. Okay, so it form at different positions, but we consider as P here. So S1, S2 are two slits. Then the S1 to P and S2 to P, there is a small path difference that is called delta. Okay, suppose S1 to P the wave travels like this, and S2 to P the wave travels like this. They combined at point P. If a crust and trough combines here, P at position of P, it gives a dark fringe, a dark shadow. If at this position a crust and crust, okay, combines, then it gives a bright fringe. Okay, so let us discuss this. Let the distance between slits and screen is capital D. This is capital D. Slits, two slits and screen. The separation between slits S1 and S2 is small d. This small d, S1 and S2. Consider a point on screen C situated at a distance x. This is P at a point is P. This is point situated at distance x from OQ. This is x, this is P. The waves from S1 and S2 have same wavelength and amplitudes are different. The first wave amplitude is A and second wave amplitude is B. The path difference between two rays is delta. This is the path difference. This is lengthy, this is somewhat short when compared to this ray. Then the respective phase difference is considered as pi. Okay, now we have to derive the expression. So let the displacement of the first wave y1 is equal to a sine omega t. So here the wave represents a simple harmonic equation. This is equation number 1. And y2 is equal to, this is second wave, b sine omega t plus pi, because there is a small phase difference between these two rays. So the total displacement y is equal to y1 plus y2. Then y is equal to a sine omega t plus b sine omega t plus pi. Then simplify this equation. A sine omega t plus b into, this is looks like a sine of a plus b. So sine omega t cos pi plus cos omega t sin pi. This will be then a sin omega t plus b into sin omega t cos pi plus b into cos omega t sin pi. So I distributed b here. Then now take common factor of sin omega t. So a plus b cos pi into sin omega t plus b sin pi cos omega t. Okay, this will be displacement of the resultant displacement of the two waves. Here this is equation number 3. Here a and b represents the amplitudes of the individual waves. This a, this b represents. Now let r be the amplitude of resultant wave. If r be the amplitude of resultant wave means the combination of a and b. So let this term a plus b cos theta is equal to cos pi is equal to r cos theta. Similarly b sin pi is equal to r sin theta. This is equation number 4 and this is equation number 5. Now we have to find r. Now we have to find capital R value, the resultant amplitude of the two waves. So for squaring and adding of equation 4 and 5. Now squaring and adding of equation 4 and 5. So squaring a plus b cos pi whole square plus square this b square sin square pi is equal to square this r square cos square theta plus r square sin square theta. Now expand this a square plus b square cos square pi plus 2ab cos pi plus b square sin square pi is equal to, take r square as common, so cos square plus sin square, this is cos square theta plus sin square theta, this becomes 1. Now take common factor of this b square, so a square plus b square into cos square pi plus sin square pi plus 2ab cos pi is equal to r square, because sin square theta plus cos square, this also equals to 1. Therefore r square is equal to a square plus b square plus 2ab cos pi. This is the resultant amplitude of waves. So r is equal to root over a square plus b square plus 2ab cos pi. This r means the resultant amplitude of the two waves. Now here if a is equal to b, that means the amplitudes of two waves are equal, then a is equal to b, then r becomes a square plus 2a into a cos pi. Here I will replace a at b. Okay, now this will be 2a square plus 2 into a 2a square cos pi root over. Now 2a square into 1 plus cos pi, then 2a square root over 1 plus cos pi means 2 cos square pi by 2, since cos pi 1 plus cos pi is equal to 2 cos square pi by 2. Since so that is equal to r is equal to 2 into 2 4 a square cos square pi by 2. This is root over. Then therefore r is equal to, so the root and squares will be cancelled, so 2 a cos pi by 2. This is the resultant amplitude of the two waves of amplitudes a and b, or a, two amplitudes a. Now the intensity of resultant wave, so intensity I is equal to amplitude r square. Amplitude square, intensity is nothing but amplitude square. Therefore I is equal to r square is equal to 2 square means 4 a square cos square pi by 2. So the intensity of the wave is I is equal to 4a square cos square pi by 2. Then for maximum we have to find here conditions for maximum and zero intensity, that means maximum and minimum intensity. So for maximum intensity we have to put this pi value. Pi is equal to pi, this expression I will be maximum at pi is equal to 0. If I put 0 here, this cos value will be 1. So 4a square into 1. So that will be maximum intensity. At next situation, this is 2 pi. If I put 2 pi here, 2 gets cancelled. Cos pi will be -1. -1 square means 1. Again I is equal to 4a square. Then 2 pi, 4 pi, 6 pi and etc. for maximum intensity. So I max, for maximum intensity I max is equal to 4a square into cos square pi means 0 by 2. Cos square 0 by 2. So this will be 1, that is equal to 4a square maximum intensity. Next thing is for minimum intensity or zero intensity. For minimum or zero intensity, that means I must be equals to 0. Now again I have considered 4a square cos square pi by 2. So minimum or zero when pi is equal to pi, again 3 pi, 5 pi, 7 pi and etc. If I put this pi here, then what happens? I minimum is equal to 4a square cos square pi by 2. Cos 90 means 0. 0 square means 0. So 0 into 4a square means 0. Therefore, I minimum is equal to 0. If I put 3 pi here, 3 pi by 2 is 0. When multiplied with 3, that becomes also 0. Then the intensity becomes 0. This is the final expression. Okay, then you have to remember these things. For maximum intensity, even number multiples of pi is required, 0 also. For minimum, for 0 intensity, the pi value will be odd number of multiples of pi. Okay, this is 4 marks question, very important question. Okay, thank you.